In this small video, I want to share with you 4 practical examples, 4 small case studies that illustrate a little bit the broad program we address in the masterclass Leading Intelligent Engineering. And in this class, on the first day, I always build a framework to really discuss how digitalization and algorithms are changing the way how we design new products and services. And I differentiate 4 different pillars for different fields of application. The first is called Predictive Enterprise. If you work in manufacturing, you may have heard about predictive maintenance. And can we predict by an algorithm the next big innovation? That would be super cool. But actually it's not science fiction, it's already here. There's a company called Choosy from an MIT grad started in Boston. And what she does is first having one algorithm that in real time is scanning Instagram for trending fashion. And then she has a second algorithm that automatically generates new fashion items based on the trends identified by the first algorithm on Instagram. Then she has a very quick manufacturing plant in China that within 2 weeks produces small samples of these fashion items. And then a third algorithm that sells these items to followers on Instagram that based on their past postings probably will like the algorithm designed fashion and buy it. And if they do so and this collection becomes successful, they sell the designs to big manufacturers, retailers as a vetted collection. And this entire process takes place in less than 3 weeks, from insights to market launch. So algorithms designing fashion? Yes. Algorithms defining your next product? Well, we'll want to explore it. So that's the first pillar, predictive innovation. The second pillar we called the collaborative front end. That's actually something we talk under the umbrella of open innovation about for quite some times, but it's just happening nowadays in stronger realization. So an easy example of a company I worked with actually in Germany, one of our big famous automotive OEMs. And you know, in the high-end cars you have a motor that is closing the door automatically of the trunk, but also some of the side doors. And actually if in your cheap car you put your finger in the door and slap it and you break your finger, it's your fault. But if your finger is in the door and the motor of the car is somehow closing the door, you can sue the manufacturer. So this company was looking for a sensor that can detect a finger, that is in the door. They couldn't find a manufacturer for this sensor, as this was really a new challenge. So they went to an open innovation platform and put out a request for a sensor of these characteristics. And who responded? Well, actually it was a manufacturer of sensors from the agricultural industry from Denmark, a very small specialized company that made sensors for milking robots. You know, with the milking robots of cows, you need some sensor to place the robot at the udder of the cow. And actually it turned out that a cow is not so different to the hands of a finger, the hands of a human. And they found this manufacturer and it was a magic connection. But just because of utilizing an open innovation platform. As no one in the German automotive industry would ever have looked, in the agricultural business to find a sensor for the high-end cars. And no one in this Danish small sensor manufacturers would ever have thought that they could make business with a big German OEM. So making an unobvious connection, this is one of the core abilities of these new kinds of open innovation platforms around this pillar of collaborative innovation. The third is really cool. It's digital design and engineering, in the end really having algorithms coming up with new designs. And this is something what has been out there in science fiction literature for quite some while, but it's now happening. And Tim Simpson, the colleague who is teaching this class with me, would be the perfect expert to share more about it. But he will show you a real life example where they trained an algorithm in the concept of what a boat is, by just showing the algorithm like thousands of pictures called in Google of boats. And somehow the algorithm understood the concept of a boat. And then you use a specific kind of AI, and this generates just a new form of boat. Then you put it in a simulation system. Actually, Tim is using Unity, a game engine for computer games, but it actually is perfect also to engineer real commercial products. And so algorithm designs a new form of the boat. It puts it in the simulation engine, and let's simulate testing the boat on the water. And the first 100,000 times this new virtual AI designed boat will fail. It immediately sank. But then at one point the computer came up with a design that actually works. And then it will iterate and iterate with a performance function on and on. And over the course of a night, the algorithm have generated 250,000 different designs, tested it in the virtual water, and in the end, you get a new raceboat design that actually works. It looks very, very scary, a little bit different, but it works. And so we really have new freedoms of design here. The fourth pillar is the business model dimension of leading intelligent engineering, and that's the upcoming of smart product ecosystem. Think about most products nowadays you get in a smart version. There are smart lights, smart cars, smart watches, and so on. And what does it mean? That a physical product is enhanced by digital services, an app that somehow provides additional value connected with a smart product. And this is one of the biggest engineering challenges. And actually we don't do it in a simultaneous engineering way too often nowadays, meaning that we design the hardware at the same time when we design the ecosystem. But in the class I will share an example of a new sport shoes we did with Adidas, the German sport shoe company. It was a service factory project. We really designed a new sensor-enabled shoe for running. It's a performance shoe, but the main task there was not to put sensors in the shoe. Well, actually it was a task and there's still some technical challenges, but this is very doable. But it was to create a meaningful ecosystem, and not just apps, but a data collection, data sharing platform, a user community, so that you can create a very scalable, affordable running experience for many, many people. And the idea is to give a high-end personal trainer, and the advice you get, not just with regard to running, but also nutrition, health, and so on, in the form of a scalable app. And so the engineering task here becomes much, much larger than to have a product with embedded sensors and software, but it's really the design of the ecosystem. And that's the fourth pillar in our leading intelligent engineering framework that we will discuss in the class. So these were rather simple examples from the consumer good industries. But in the class we want to explore with you more sophisticated examples also from industrial companies. And I'm looking very much forward to see you perhaps in the future in the class and also learn from your experiences, your cases along these four pillars of intelligent engineering.